Hello, welcome back. Hope you enjoyed your lunch break. Hope you, obviously you weren't able to do our normal sort of networking that we normally encourage at these sorts of events, but apologies for that. But hopefully you enjoyed a nice sandwich in your own kitchen or workplace. So the next session we're going to be taking you through today is how you can merge your manufacturing processes with BIM processes, and myself and Robin are going to be taking you through this one. Before we get started, I just want to ask you a quick poll in the Zoom chat here, which is, here it comes now. What does BIM mean to you? And of course the four possible answers are a load of made up rubbish, more work for more than it's worth, an opportunity for you to sell more, or more efficient workflows. So if you could put your answer in the Zoom chat, that would be great. I'm just going to give you a few seconds here just to populate the results. Okay, well that was fascinating. We've got the results here. So by the look of things, most of you went with it means more work than it's worth, which is quite interesting. In fact, most of you went for the more negative comments towards BIM than the positive ones, but that's very interesting. So we're going to be looking first of all at fundamentally what BIM is. So the construction world, in my mind, is fundamentally different to the manufacturing world. Trust me, I know we've got both a manufacturing team and an architectural team here at Man & Machine, and they are fundamentally different types of people. But traditionally, if you are making equipment that is used in the building of any description, of course, now you probably as manufacturers adapted your own processes internally probably 10, 20, 30 years ago in order to streamline your businesses. And you've probably been evolving that process through the last, through that time. Now the issue with the construction world is they're only really just getting to grips with digital construction. Now the term BIM, or digital construction as they're preferring to call it these days, it's been around for a fair few years now, and any of you that sell to architects or MEP consultants or structural engineers or even the construction companies themselves, you know that the requirement on you in terms of data exchange has changed quite a lot in recent years, from predominantly, I guess, a 2D exchange of data to a much more feature and data rich set of deliverables. It's taken the industry a little while to really get to grips with what that actually means in terms of the expectations put on suppliers like you. But more recently, with the introduction of ISO standards, they're really putting the T's and C's down in place so that us as manufacturing supply chain, we can really get to grips with what is required on us. If you think about it, it's very similar to what the automotive sector did probably back in the 80s or 90s, where they sort of changed their processes and then they pushed that expectation down on their supply chain. Now, yes, there was a bit of a change and additional cost and a bit of disruption downstream to their suppliers, but ultimately for the automotive industry, the car was able to be made quicker and more efficiently with less money. Now, in my mind, that's pretty much what BIM is about, and it's about the industry trying to get themselves standardized. Bit of change for our suppliers, but the end goal is the same. Today, if you already supply to the construction world, then you're probably already receiving better data, and you're probably expected to supply your products and your data in a very specific way in order to integrate your products into the entire project. The first challenge really is that in the manufacturing world, we tend to work to a very small tolerance. We tend to think of a 3D model as holding every nut, bolt and washer with a very small and tight tolerance set, an accurate model. Unfortunately, in the architectural world, they kind of work to a tolerance of about, well, probably about this, to be honest. The other issue is that more often than not, you've got these nice feature-rich models, and they are feature-rich, but then don't necessarily hold the important metadata that the BIM manager or the facilities manager on this project actually need. Warranty information about the product and the throughput and such. Of course, the other issue is that we all know architects, and they do like to change their minds quite often. They don't actually tend to understand what effect changing the mind has downstream on manufacturers like us, especially if you've already started tooling, for example. In my experience, the real points to consider when you're looking at a manufacturing to BIM workflow really depend on your customer. Now, it might be a simple one-way transfer of data, say at the end of a project, or it might be something that needs to happen both ways, in and out of Inventor, back as architects change their mind. And it also depends on how much work you do and how many different types of products you have. You really need to work out how to do this transfer and what level of detail and information is required. And is it a manual process? Do you pay someone to redraw your products in something like Revit? Or perhaps do you employ someone specialist in-house to be able to do this for you? All of this is redrawing. Or perhaps do you automate the thing? Do you automate the creation of BIM content? And you're going to need to consider a number of factors when you look at this. And this is something that we do quite often, and we can offer our advice. Now, the other thing to note here is that Autodesk products have evolved over recent years, and Robin's going to take you through some of that in a moment. But before he does, I just wanted to introduce you to an example of one of our customers. So one of our customers is Storm King. Now, Storm King are the largest specialist manufacturer of off-site prefabricated components. Now, when we started working with them a number of years ago, they were already having demands on them to supply LOD4 BIM models to their clients. Their clients typically are the home builders, and they supply prefabricated GFP products, these sorts of canopies over the front of doors. You sort of you see in all sorts of housing estates all over the country. There was quite a few of different product sets, quite a few different products, you can imagine their projects were massive with lots of different content. And they were actually considering buying Revit from us. They came to us to ask for Revit, and they wanted us to train an individual in-house to be able to use it, to be able to redraw what they already had created in Inventor, but in a format that their customers needed. Now, what we actually did was we worked with Storm King on a way to automate the creation of this BIM data, essentially using iLogic and all triggered within the Vault, so that their designers essentially can concentrate on designing good products inside of Inventor. And when Vault gets to a certain stage in the process, what happens is it triggers an event to run iLogic, and it recreates the data in a neutral BIM format, pulling the IFC data, all the metadata from Vault, all into the same file in the right location. So rather than messing around with data exchange in the background, all of the models are created at the right time with the right information. And more importantly, their customers have absolutely no reason to look elsewhere because all the data is there for them. Now, Robin, my colleague, is going to take you through the specifics of this example, but he's also going to look at a more efficient workflow of taking data in and out between Revit and Inventor.
Thanks for that, Simon. So what I want to take you through is, firstly, this specific workflow that Simon's just been talking about with Storm King, because it's a really interesting story, how we managed to take something that is otherwise quite mundane, quite manual, and pretty time consuming, and automate that in a way that really integrated this into their existing workflows. So essentially what we're talking about is the fact that as a client, they're a heavy Autodesk Inventor user. And as you can see from the screenshot, a detailed model as you would expect. That model has assemblies, has parts, has fabrication drawings, and enough information there to go and manufacture these components out of GRP. But what they needed to do, as Simon's already alluded to, is produce Autodesk Revit friendly models. So they were being asked specifically for BIM models. Now that's a little bit more than just a Revit model, as many of you will already know, in that, okay, we need to have a good level of detail in that model. I mean, we've got a fabrication model here, so we've got something that is fundamentally too detailed from a BIM perspective. There's just too much information on there from a geometry perspective. So what we need to look at is extracting enough of that fabrication detail so that we can see a good representation visually, but also tie into the high level of information that we also have against that particular design. Now, from a building information modeling perspective, the information really is master, and actually you could argue more important than the actual geometry itself. Many times you will actually see inside a BIM model a very simplistic visualization of a component, even as far as a cube or a sphere or cylinder in some cases, and they are then built on with a higher level of information that explains what that component is, what it's used for, defining it in a lot more detail than actually what it can be seen visually, and that's more important. So what we have with Storm King is a great quality 3D representation, which could be simplified if necessary. But we also have, as you can see on the screen, a number of custom iProperties that are defined by the level of definition requirements in the UK for BIM for that particular type of component. So what uniclass classification is it? What's its description? Does it have any specific parameters that are important? And all of those are stored both inside of Inventor in iProps and also directly through Vault through the property synchronization between Inventor and Vault. So if we could simply take that detailed fabrication design and simplify it, perhaps through the use of shrink wrap, attach all of those metadata to be able to get a BIM content export out, then we have the ability to create a Revit family file or an IFC file or an ADSK component file almost at a press of a button. But we didn't want that to be at a press of a button for Storm King in that case. We didn't want the designer to have to remember to go through that BIM content process inside of Inventor. They already had a very sophisticated Vault setup with custom API, with the ability to drive information direct from ERP or other systems within the business. So why would we not look at leveraging that integration with some further custom code, custom development, to be able to automate this entire process end to end? So that, for example, as part of a workflow or a life cycle inside of that Autodesk Vault system, perhaps when a file gets sent to be released, or perhaps when a file is set to customer approved, whatever it might be, or even share with customer, Vault kicks off a custom workflow using Cool Orange Power Jobs, for example, and maybe some clever custom scripting language in there using Windows PowerShell to go and automate the BIM content creation procedure inside of Inventor. And that's the process that I want to share with you very briefly before we move on. So inside of Storm King's Vault, we can see that in this case I kick it off manually, but by selecting an IDW, we have some custom API integration that shows me if BIM files are there. They show me BIM properties that are defined within the file, and they allow me to choose whether something should or shouldn't be included as part of the BIM export. Now in this particular example, we chose to generate these files manually because we didn't actually want to go through and kick off a workflow on this particular live design file. But what you can see happens is it kicks off a job inside of Job Processor. And if I just give this a couple of seconds, what this does is it will automatically go ahead and create a shrink wrap So it simplifies that main assembly file, and that is closely followed by both a Revit file, RFA family, an IFC Industry Foundation class file, and an ADSK file. And once they're created, they are checked back in and up-revved, up-versioned as necessary into their Autodesk Vault system, all automatically based on those series of automated rules. That process means that they can just carry on with their design work and pushing their life cycles through Autodesk Vault, and it will automatically create BIM content when they need it. It will appear in Vault. They can then share it with the customer as necessary. That's great workflow for me, and it's things like that that we really thrive to help our customers with. Not just solving a problem, but actually embedding it with an existing solution and some existing workflows, which means that actually they haven't got to go through a change management process. They've got something that's embedded with the way that they work, which from my perspective is great. So I kind of want to push that a little bit further and share with you how Inventor as a product has really matured in this BIM interoperability over the last year or so, specifically with its AnyCAD functionality. So AnyCAD has been inside of Autodesk Inventor for a number of years now, and it won't be a surprise, this particular slide that I've got up on the screen, which shows that we've got interoperability with the likes of CATIA, with SolidWorks, with step files, a number of different other products outside of the Autodesk ecosystem, but also the likes of Fusion 360, AutoCAD, other Inventor files for using older Inventor versions alongside, and even Autodesk Revit now has had an upgrade in that AnyCAD functionality. So we've been able to bring in Revit files into Inventor for a number of years, and actually it's always worked pretty well. But what we have now with 2021 is the ability to really drive some nice interoperability between Inventor and between Revit, which I'm going to show you in a few moments. What this means is I can bring in an intelligent Revit model that understands what all the walls are, what all the floors are. If there's any ducting in there, group them all together so that they're intelligent, they know what they are. So this really, as fabricators and manufacturers, gives us the ability to lean on the Revit design, gives us the ability to reuse information from the Revit design to both make our products more informative, make our products more accurate, and hopefully reduce unnecessary change. So what I'm going to show you is a bit of a workflow between Inventor and Revit. Simple as that. But actually the bigger picture of this is actually you're looking at a much wider workflow. So if you look at the bigger picture, we have something that can communicate all the way from Revit to Inventor, yes, but via the likes of BIM 360 docs and Autodesk Vault. Autodesk Vault and BIM 360 docs have been able to talk to each other for a number of years now. But actually, if you look at the process I'm about to show you, but again, think outside the box. We're limited on time today with this virtual session. So just think about what the story is behind what you're seeing. So whilst you're just seeing Inventor to Revit interoperability, imagine that as a manufacturing designer, you're going to be checking in and out of Autodesk Vault. But in the background, that Autodesk Vault could be downloading the latest architectural file from BIM 360 and putting it live ready for you to link inside of Autodesk Inventor, sorry. It might be that you want to share your latest Inventor design or share an IFC file from that Inventor design to the architect or to the specialist designer. All you have to do is check it into Vault, change the status, and that could be automatically synchronized up to BIM 360 so that the architect or the specialist designer, the contractor, whoever it might be, has instant access to that as soon as it's readily available. That functionality is not in the future, that is here and now, and it's gaining momentum day on day, month on month, year on year. We don't have the time to show you that vast capability today, but what we will show you now is the ability to link with AnyCAD Revit files intelligently into Inventor and have a succinct link between the two applications. So let's just jump into Inventor and Revit and we'll take a look. Okay, so we've just jumped into Revit 2021, specifically point one in this demo. And the first thing I want to do is just explain the difference between a Revit family and a Revit project, because that's important that you understand that throughout this short demonstration. So we're going to start off with a Revit family file. I just explained that, from our perspective, this is kind of an assembly, if you like. You could argue and say it's a part, 'cause it doesn't quite have the intelligence to know that there's a bomb in there, if you like. But we have different components or features. So in this case, we have some extrusions and maybe some other extrusions or lofts in there. But there's not. You don't get fabrication detail. You don't get that understanding of how many components and how many iterations of those components or instances of those components are there. But what we do have is a good level of information against those, so a good property level or understanding of that property level inside of Revit. Now, those Revit families, RFA files, are typically placed into an RVT file, which is a Revit project. Those Revit projects are typically much bigger than an individual component, so an entire building, for example, whether that's an architectural design, a mechanical, electrical, plumbing design, or a structural design. Revit supports all of those. In this case, we're looking at a simple architectural design of a building. And if I just jump in and just go into my main 3D view, just unlock the view here, we can see that we've got a fairly detailed model. It's not by all means to the nth degree detailed, but we've got a nice looking model with both some exterior building components, walls, windows, doors, some facade elements, some curtain walling, panels, some escalators, some slabs, some lighting, so on and so forth, and some columns. So we have a building. Now, all I've done is, because we don't need that breadth of information in Inventor for what we're going to do today, is I've just created a simple view called 3D Exterior Solar Shading in Revit, and there's just a filter on there to turn off that stuff that I don't need in Inventor. So I've created a filtered view in Revit that I'm going to use to import into Inventor. And maybe the spec of this particular project here is that we want to go ahead and create the facade that the architect has laid out. So in this case, we've got those Revit families that we saw, and they've been placed around this building. And what I want to do is I want to import that into Inventor, reuse that initial thought or that design, that idea, and then develop it into something that can be manufactured, that we can go and fabricate, put together, and then deliver the right size, the right shape, and the right fitting to go on that building. So I'm just going to leave Revit open, jump into Inventor, and just go through a couple of processes first. So majority of you on this session are Inventor users in some way, shape or form. So just to reiterate one thing that we went through earlier, is what I have in Inventor is intelligent component design. So if I look at the same facade that we just saw inside of Revit, we have something that's far more detailed. So we have, yes, still got the slats on the top here, but those slats are fastened to these sheet metal brackets, which are in turn fixed to the main material on the facade with some fasteners. We have insulation material in there, and typically something that is a lot more detailed and manufacturable from that perspective. In Revit we had a very simple component with a few extrusions, and in Inventor here we have 130 different components, 25 of which are unique, and that means I have a fabrication bill of materials that I can look at from a model data perspective or parts information, which is going to show me lengths, widths, base quantities, areas, different materials, so on and so forth. It also means that of every single one of these components, I also have a drawing, whether that's an IDW or a DWG. I have something in there that is updated live from those assembly files or from those part files. So whether it's a GA like this with an exploded view and a parts list, or whether it's a specific view of one of these individual components, I have a fabrication model, a manufacturer's model, with the different drawings and GAs that link with it. And to remind you from the sessions that we had this morning, we also have things like iLogic. So I'm not going to go through all of this again, If you missed the session on iLogic this morning, be sure to go and catch up on our YouTube channel. The joys of live demos. That's just jumped onto a different screen, so let me just move that across. Little top tip of the day, that is, if you press, if you lose one of Inventor's dialogues off screen, hold down Alt, hit space, M for move, and then just use your arrow keys. But yeah, just as you saw earlier this morning, with this particular component, we've got an iLogic form, so we can come in and change the number of slats. We can come in and change the height, change the width, and the model updates for you automatically. Again, I'm not going to go through that in the same detail that we did this morning, but to explain that we've maybe taken that spec from the customer and we've detailed it, we've defined it, and we've got something that we're now ready to maybe put on the side of the building and start collaborating with that architect. And that's what I'm going to do now. A little bit Blue Peter style, just to save time, because we are limited in our presentation time today, is I'm just going to open up a blank assembly template that's ready to receive that Revit file. And whilst I'm in there, I'm just going to jump up to my my drop down, and I'm going to say that I want to place a CAD file. So I want to place an any CAD component. And from there, it's given me a whole raft of different options. But I'm just going to use my frequently used subfolders to jump to my Revit dataset. And I'm going to choose to import this Revit file that we've got in front of us here. So with that Revit file, I'm going to say open. It would take a couple of seconds the first time, and dependent on how big that Revit file is, it might take a little bit longer or a little bit less time to load. I'm running on a pretty good spec laptop at the moment, so it loads pretty quickly, but likewise, it's not the biggest or the most complex file in the world. So when we're importing, we can choose to import as a reference, which means it keeps a live link between the Revit file and the Inventor file, which we will use today. It's fantastic. But it might be that you don't want that. Maybe you want a nail in the ground at the point at which you downloaded that, so you would just choose to convert the model. In this case, let's reference it. Let's use that 3D view that we built in Revit, so the 3D exterior solar shading view. And I'm just going to be lazy, to be honest, and just import everything. You could be selective if you wanted to, but we created that filtered view in Revit to save us having to do that again in Inventor. If that wasn't the case, we could filter down to just the elements that we want to see in Inventor. I'm going to press OK. Inventor just gives me a little warning to say you're importing a whole Revit project. It might take some time because it could be quite detailed, obviously. In this case, again, I've got a nice high spec machine in front of me, and actually the model's not massive. So I'm just going to import it all in. And I'm going to right click and just place grounded at origin, just to make sure that the 00 of the RVT Revit file is at the 00 origin point in Inventor, just to make sure that those coordination points are succinct between both Inventor and Revit. That's important to make sure that any cross collaboration works moving forward. And actually what you get straight out the hat is a really nice visual rep of that building. For years we've had interoperability between materials, whether it's Inventor to Max, whether it's AutoCAD to Inventor, Revit to Inventor. Materials kind of look and feel the same between the applications, which is great because it means that I can bring this straight in and it looks the part, it looks as it did in Revit, and I can instantly see what's going on. So first and foremost, we have a great visual fidelity on here. The second thing we can do is if we just jump and have a look at the model browser, we can see that nowadays in Inventor, that import from Revit is far more intelligent because before you just got a load of solids, but now you can actually see that we've got different classification of components. So we've got a folder for columns. If I select the folder, it selects all of the columns inside of that design. If I go into the columns folder, it shows me that we have two types of round column, and we can individually select those groups or indeed select individual components if we want to. And obviously use all of the benefit that comes with Inventor at that particular point in time by saying, go and grab one individual instance. I could right click that and I could say that I want to find that in my window, should I want to. So you get all of the functionality that you would expect once you've brought that in and imported it. Now, what we want to do with this particular design is we want to take that initial idea, that fabrication design that the architect's done. And as I've said, we want to embellish it, we want to detail it. We've already got that fabrication model. And from this morning session and just now, you've seen that that's a parametric model. So it can resize, it can chop and change to suit. So what would be great is if we can come in and maybe use some, in my opinion, hugely underused and underrated Inventor functionality with iCopy to take what exists and match it to the requirements of this building. Again, I'm going to do a little bit of Blue Peter just to save time to make sure that we don't run over because we've got a tight schedule today. But I'm going to replace all of these facade elements with Inventor versions ready to then push this back out to Revit. So I'm just going to close it down for the purpose of this and then just go and open up one that's ready to go. So let's go and open up this particular assembly here. We'll just give it an update just to make sure it is running the most up-to-date version. Just going to take a few seconds. And with iCopy, I've put a little bit of pre-intelligence in here to basically add some work points. For those of you that haven't used iCopy before, what it's going to do is it's going to allow you to place a component, intelligently copy it and scale it maybe up, down, resize it, big or smaller, or even follow an existing pattern to give me something that, that is a lot easier to work with. And in this case, you can see that I've placed one detailed version of my facade just here, but I've got a number of areas where I need to go ahead and place another one. So first things first, inside of here, now I'm just going to come to Insert Panel just to have a saved view here. And you can see that we've got this panel on the left. This has been placed as a single panel. If you remember from a moment ago when I opened the panel, it was quite small. And certainly this panel here is much bigger on this west facade. So what I'm going to do is I'm going to say up on my my ribbon, I want to choose iCopy. And if, like me, you're not used to seeing it underneath this pattern drop down, I used to have it up here on the ribbon. You can just right click any component on there or any tool, and you can say that you want to move that to the main panel to unhide it if you like, so it's more obvious. Tools like this, in my opinion, they shouldn't be hidden because they're so useful. If I go ahead and choose iCopy, I'm going to go and choose that master data set that I first opened, which is just that parametric panel, and I'm going to choose Open. And what that'll do is it will just bring that, as you can see, short facade or small facade, if you like, into the model ready to place. But it's going to give me a constrained iCopy. So it's giving me 3 options to place that component in my model. Now, this is because inside of that iCopy component, I've got 3 work points, one at the top left, one at the top right, and one at the bottom right. And what that will do is it allows me to then scale that component up or down. So taking a standard component and just adding 3 points that again used to parametrically size that component, it makes a big difference when you're working on files like this. So all I'm going to do is just scroll down and just show you that I've just got in here, you can see if I hover over them, just some points that are pre-set up. So all I've done is just placed points in the right place, in the file. And I'm just going to say the top left is my top left, the top right is the top right, and then the bottom right is the bottom right. And what you'll see is that that component is now parametrically resized to suit. I'm going to press Next. And as part of that, it's going to ask me what I would like to do. It's a copy reuse dialog box. So do you want to copy the selected object or do you want to reuse? Well, typically I want to copy it because I've made it bigger. That panel is likely not going to be the exact same size as the previous one. So I want to have a separate version of the panel. So I'm going to leave it on copy, but reuse any standard parts. Hit Next. I'm more than happy with the names, but if you specifically wanted to name these, you could. I'm just going to say OK. Give it a couple of seconds. It will put that component in, place it into the assembly, update the BOM, and resize everything to suit. So I now have a facade that's sized specifically for that curtain panel. I'm going to do exactly the same thing again with a slightly different process. So if I just go into this Insert Panels view over here, I've basically got a further 4 panels that I want to place, but I'm going to do that with a pattern. So the same thing again, I'm going to choose iCopy. I'm going to go ahead and choose the same assembly and open it up. And then on that particular component, rather than placing a constrained copy, I'm going to say Pattern. And against that pattern, what I want to go and do is pick my work points that I've got on my south elevation. So in other words, I've just replaced those same 3 work points in my assembly, ready to receive data. And then all I'm doing is saying top left is my top left, top right is the top right, and the bottom right is the bottom right. You'll see that what's happened in the background, just behind this dialog box, is it's placed one instance of that facade panel. But these other ones, it's highlighted the work points. If I hit next, again choose to copy the data, and then again name them as I would like before pressing OK, this time it's going to place, resize, place, resize, place, resize, based on the pattern of work points that I've got there. So I'm putting a little bit more time and effort into that initial design to place some work points, but based on that, I'm getting something that's then far easier to work with. So, you know, I've got something that works. It automatically scales them up. It's so much easier to work with, which is absolutely fantastic. Now, we've got huge benefits here. So, rather than saving, which is just going to take a little bit of time based on all of the different iCopies that I've done, I'm just going to close this down. And I'm just going to open up one that's at the exact same point. So let's open up this export for BIM here. Just to show you, in my opinion, the best part of this. So, I mean, iCopy is great. It's been around for years in Inventor. I love it. But actually, for me, this next part is key. Because what this next part allows you to do is have a succinct link between Revit and Inventor. So I've got a dimension here. Okay, so let's go into a Revit update. So I've got this wall-to-wall 11-meter dimension. I'm just going to jump into Revit. Note here the update icon. I'm just going to jump back into Revit and go to a saved view inside of Revit. And I'm just going to select this wall here. And with this wall selected, I'm just going to say activate dimensions, which shows me that I've got, you know, a dimension. Now in Inventor, that dimension was linked to the end of this wall. So I'm just going to go and do the same thing. But then I'm going to change that dimension to 12 meters, which is obviously a bit of a design change. I mean, we've already said that architects like to change their mind on things, which is absolutely fine. But based on that, all of these facades change, and they'll change based on the curtain pattern in the background. But if I just save this file in Revit now and go back to Inventor, you'll see that this is prompting for an update, which is exciting, because if I press update, it takes a couple of seconds, but this should go in and read the changes from my RVT file, and they will pull those back into Inventor. And not only will they make those changes to the Revit geometry, but because of the way that I've modeled my facades, it will update the facades as well. All I need to do is a little rebuild all. You'll notice that the fasteners haven't moved here. So I'm just going to go to manage and just hit rebuild all, just to get it to reposition those fasteners, just based on the iLogic rules that I've got in the background. But what we have there is a live link and a live update between a changed Revit model and the Inventor model, which for me, that's fantastic. And that's something that is, you know, for anyone in this field, that is second to none. What we can do now is export that out to Revit. And we've got a couple of different options. I'm not going to go through them in the nth degree because, again, we just don't have time today. But once you get to a point where you are happy with that component, we have the ability to push it out. If I go to environments, we've got a BIM content option here. Now, I don't want to send this Revit building, so I've got a view rep, which is just my facades. Everything else is turned off. And I can go ahead and say export BIM content. Now, in this example, we've actively taken part in more than just a single component design. We're taking part in the actual shape and build up of that building. So I wouldn't export a Revit family for this. I'd actually go out as something like an IFC, so it's coordinated correctly with the building. If I just had a single panel, then I'd go out as an RFA, but it's more than that, it's bigger than that. So in Inventor, what we would do is we would take the panel, we would go into author building components, we would select some options in here, such as the Omniclass number. We don't really use Omniclass in the UK, we use Uniclass. Inventor at the moment only supports Omniclass, which is a shame from my perspective, but it's quite easy to create a mapping there if you know the two systems well. So we can create a classification, we can choose whether or not to export model data with that, should we want to. And then from there, we can go ahead and export our building components. We can export them out to an IFC, and we can hit save. The IFC format writing out takes a little bit of time, so rather than you watching a progress bar, I'm just going to go over into Autodesk Revit and just show you that from inside of Revit, we could say manage, insert, manage links, and you can see that under IFC, I can add an IFC file. From there, I could say exported file and go and grab the IFC file that's been put together inside of Inventor and open that up inside of Revit. Takes a couple of seconds to reference it, but then we will have live Inventor data inside of Autodesk Revit, giving you a round trip. If you imagine that demonstration, but controlled by Vault with a check-in and a check-out that's been synchronized directly with BIM 360, we've got something that works extremely well. So, we have something that just does what you would expect it to do when you expect it to do it. So let me just come in here and select these facades and grab them all, hide them, and there we have our Inventor. Let's just unlock this view. Our Inventor design directly inside of Revit. Link that with other tools inside of your collection, such as Navisworks to do clash detection, and you've really got something that works extremely well. And really for today, that's kind of all I wanted to show you. So I'm going to hand back over to Simon just to finish off this session with what that means in anger to you guys actually working on this stuff.
Thank you, Robin. What an interesting presentation that was, and great to see some really new functionality coming into Inventor with the BIM workflows added there, especially the iCopy stuff. That was really interesting. Really great to see. Great to see that functionality coming in. Hopefully useful to a lot of you that have been watching. It's quite clear to me that the world of BIM is quite complicated. There's a lot of things to go wrong, a lot of things to consider. Whether you're going to fully automate the program like Storm King, or whether it's a simple one-way transfer or a bi-directional link like Robin showed you with the iCopy. We're here to help. So Man and Machine, we've got a lot of experience in both the manufacturing and the architectural world, and we're here to sort of make that link. The worlds are definitely converging, and we're here to help you. If you've got any specific questions, please use the Q&A box at the bottom of your Zoom bar. We're going to be here online all day to answer your questions, whether it's now or whether it's in the next, for the rest of the day. So please use the Q&A box and we'll come back to you as soon as we can. The next session coming up is going to be around digital prototyping. So we're going to be taking a short break now for 15 minutes or so. And then Frankie and Pete are going to be taking you through digital prototyping using simulation tools to really understand what your products are doing. So bear with us, stay with us, and we'll be coming back shortly.